Hello, welcome to the session 4 SystemVerilog for verification short videos. Today our topic is basic data types part 3. We'll try to cover mostly aggregate data types today, so covering structure, union, arrays, in arrays also dynamic arrays, associative arrays and queue. Today's lecture is the important one because all of these data types are frequently used for writing any test bench using SystemVerilog. So let's start with the structure. Structure is nothing but the collection of different data types. This is the same as used in other languages like C, but let's see how many different ways are there we can write any structure. So for writing any structure or say declaration, we need a keyword struct, and we can have any kind of data types, let's say logic int inside that structure, and we can access the structure using the structure name dot member name equal to some value, let's say 4b0010. So here the structure ir dot addr has been assigned a value 4b0010. Another structure is user defined structure. As we have discussed in before lectures, like typedef keyword is used to make any data type user defined. So here typedef struct, then the same kind of data types in between, and instruction. So here instruction is a type of structure. So whenever I need to have say structure declaration, I will take instruction space ir. So here ir is a structure of type instruction, which is type defined by a struct. Okay. By default, all the structures are unpacked one. But if we want to make a packed structure, we need to have keyword packed. So I will write struct packed. In previous lectures, we have discussed the difference between unpacked and packed data types. To repeat once again, packed data types can be used as a single vector. So here, let's talk about IR. I can access IR directly with say 36 bits for of logic and integer having 32. So by 36 bit assignment here, both AWDR and data will get the value as they are having the memory location next to each other. Pack structure can have either signed or unsigned data type. Unpacked structure can't be having this kind of signed unsigned because as they are not next to each other in memory, it will not be possible to assign sign bit to each location of unpacked structure. So to make a structure signed one, I need to write struct packed and signed with that. So here IR is signed, and as all the data types say bit and int are two state, my structure IR is two state structure. I can access it using 36 bits as it's a packed one. For unsigned one, I need to write keyword unsigned, and then I can have say logic and int. So this is unsigned structure, but as one of the data type is logic, which is four state, my structure is called four state structure. The next is structure literal. If I want to assign a value to structure, there is one way to assign it using curly braces and a tick. So if I want to say assign values to this structure, which is not packed one, which is unpacked, so I want to assign say int and short real. I have taken ab space c. Then I can assign it as c backtick in curly braces, first of all 0 which associates value with a, then zero point 0 which associates its value with short real b. This is how we can assign values to unpack structures. Okay. We'll try to see some example of structure into terminal. Structures are mainly used for register description of any project. Whichever project in verification you will be working on, it will be having its specification will be having one chapter called register description. So here for an example, I have taken one specification where this is the address, this is the name of the structure with some description and having access, say read write, then ro means read only, wo means write only. So here I am having the full set of registers which I will write using the structures. So now I'll show you the code I have written. Let's take this example. I have taken type def struct packed for one register named LCD time h. So here for this LCD time h, I have make one structure, a pack structure. Inside that, I have declared logic 7 down to 0 HBP according to the requirement of this register, and all the fields are there. Now, how I will use this structure is after making it, I'll be having one memory mapping block diagram here. In this, I will take the instance of the LCD time h reg named LCD time h. So this LCD time h is having a type LCD time h reg, which is having a type def name structure packed. Okay. How I will use this LCD time h? So let's say I want to read from the memory address. So I have written always block sensitivity having memory address read. Whenever there will be a change in memory address, it will come into this block. There is a case statement. And as I know that LCD time H is having a register value, say FFE10000, I will say if my address matches to FFE10000, HR data, say read data, should be equal to LCD time edge. And the same way, if I want to write into the structure, what I will do is based on always block having memory address right in case statement on FFE10000, I will say this register equal to W data, say write data. So this is how we use the structures for having memory or say registers into any project. So now here I have designed one exercise for you. You have to go through this table which is having some addresses, name of the registers and access. You have to make similar packed structures for all of these registers, and then you have to do memory assignment that we just show into the terminal. And if my register is read only, then try of writing into this register should shout an error. Okay. Next is union. Difference between structure and union is a single piece of storage that can be accessed using one of the named member data type. What does it mean? All the unions share a same memory, and they can be accessed using one of the member. For an example here, I have written say unpacked union. So by default is unpacked one. So say type def union. I am having members int a, short real b, and uni. So my uni is a type of having union. I have taken instance uni space u. So now if I want to access the say member b, so what I will do is u dot b equal to 0.0. This seems the same as structure, but only difference is the memory allocation of a and b is on to the same location. We'll see into memory location area. Before that, we will look at one packed union. If I'm saying that my union is packed, then what's the difference? All data type of integral type should be inside a packed union, and they are all are have must be having same size. So here say bit 31 down to 0 mem1, so it's having size equal to 32 bits, and another member is bit 3 down to 0, 7 down to 0 mem2. So this is multi-dimensional array, and its size is say 4 into 8, so 32. So both are having same size as well as they are having integral type, and my union is having name pack uni. It's having instance p. Now, as we talked that what is the difference between union and structure? So this union is having memory allocation like it. It's having 32 plus 32. So basically 64 locations, and this another one, it required 32-bit memory allocation. So I am having 32-bit memory allocation for both the members. There are no 32 plus 32 equal to 64 memory allocation as structure. So here is the difference. One more union type is tagged union. In tagged union, uh, in original union, there was a loophole that if I'm updating my union using mem1, and then if I'm trying to read the union using mem2 keyword, I'll be able to read it. But the value is wrong because the value was assigned for mem1. So this is a loophole of original union. Now in tagged union, what we do is value can be read only by one having tagged of lastly updated. What do I mean is if lastly mem1 has updated the tagged union, then mem2 can't read it, only mem1 can read it. How I'll do it? First of all, a tagged keyword should be there inside a union declaration. So type def union tagged packed. So this is a packed union also having two members int a1, int a2, and u. So then u space u1. So my u1 is now having type u, which is a packed tagged union. Then I need to write u1 equal to tagged a1 5. So basically, I am saying that my u1 is right now tagged with a1 having value 5. And whenever I am assigning some other variable, say int b equal to u1 dot a1, I'll be able to assign it. We will look at this example into terminal, so we'll get more clearance about it. In terminal, let's go to tagged union.sv. Here we will try to write one code of tagged union. Let's start writing it. Say int a, then I'm taking one union, so type def union tagged packed one. Inside that, one bit of 31 down to 0, say a1, and another is int a2. So both of them are having same size. You can see that having named u of type. Let's take instance of u named u1. Now I will write one procedure initial begin. Inside this, first of all, let's provide u1 value with tag. So say tagged a2 10. Here I have tagged u1 with member a2 assigning value 10. Okay. Now what I'm doing is I'm assigning value a to u1 dot a2. So u1 dot a2 should be assigned to a, and now let's display value of a. So a equal to percentage 0d and a. So that's it with this code. Let's run this. Now keep in mind that while running of code of this tag union, we need to add one more switch named LCA with VCS. Then tag union.sv. Yeah, it's compiling. It's compile clean now. So let's run it. Dot slash simv. Enter. What I'm expecting is A should be having value of 10. So A got the value of A2. Now let's try reading A1 from union, but the U1 is having tagged A2. So as per our expectation, this should shout error. Let's compile the code again and run it. Yes, it's showing error that invalid member usage of a tagged union. So as we discussed, we can't read value from a member which is not currently tagged. All right. So this is it with the tagged union. Next, we are having arrays. In arrays, there are packed arrays, unpacked arrays, and combination of both will make a memory. Let's first see packed arrays. They can be treated as single vector, as any packed data type can be treated as single vector. Which are the inbuilt data types which can be used as packed arrays? Say byte, short int, long int, integer, time. These all are inbuilt packed arrays. So when I write byte c2, integer a1, they can be represented as, say, bit signed 7 down to 0 c2. This is similar as byte c2. And if I am writing a packed array, I need to write the size of array before variable name. And this integer a1 can be written by logic signed 31 down to 0 a1. Here I need logic because integer is a 4 state value and logic is 4 state value. So this represents integer a1. This is how we can write packed structure. On the other hand, for unpacked array, I need to write the size after the variable name. So let's say logic b1 7 down to 0. Here 7 down to 0 was before c2, and now I am having 7 down to 0 after b1. So it represents unpacked array. Similarly, int a1 7 down to 0. This is basically 2D array, as int itself is a packed array. So I am having one packed int and unpacked byte, I can say. So it's a 2D array. Now if I want to write a memory, I will be having one packed and one unpacked array. So say logic 7 down to 0 mem 0 down to 255. So this is 256 cross 8 memory I have made. If I want to access any member, I can say memory of 5 equal to 0. And if I want to read from memory, I will say data equals mem of address, any address it can be. So this is how memory is being written using packed and unpacked arrays. Like structure literals, there are also array literals. We will go through it. Let's say I have one integer array, say int a 3 down to 0, so it's unpacked one. And if I want to assign all members having value 3, what I can do is tick then curly braces. This 4 curly braces 3 is a repeating operator, so 3 will get repeated 4 times. So this is equivalent to tick in curly braces 3333. So my array got value all having values 3. Another example of a multidimensional array, say int b 0 down to 1, 0 down to 2. So this is basically this array, and I want to assign values, say 1, 2, 3, 4, 4, 4. So how I will assign it? First of all, I need to write one backtick 1, 2, 3. So first row is being assigned. For another row, after having comma, I need to write tick, then 3 repeating factor and having value 4. So this is equivalent to 4 4 4, and at the end having curly braces and backtick again, because this is again one 2D array. So for one row, this one backtick curly braces. For second row, again backtick curly braces, and then combining both having curly braces and tick again. This is how array literals are being assigned. Next is dynamic array. What is dynamic array? It's basically unpacked array whose size can be set or changed at runtime. So now we are learning the arrays which are having dynamic nature. This packed and unpacked arrays, they were having static nature. Their size couldn't be changed at runtime. But now this dynamic array will be able to change the size at runtime. Dynamic arrays are declared by square braces. Example, say integer array. So int a square braces semicolon. We'll look at the example, but before that, let's go through some methods of dynamic array. We have to create dynamic array. So the method is new, having a square braces and then parentheses. This new method is used to set or change size of array. Default value will be 0. So for an example, if I want to set some value or say some size of dynamic array, what I will do is int a square braces equal to new in square braces 4. So basically, I have declared a dynamic array having size 4. Next, if I am writing like int a square braces equal to new in square braces 4 and in parentheses b. So here a is having size 4 and value of array B is being copied into the array A. Okay, so it's copy of B to A. And if I want to change the size of any array at runtime, let's say my A is already declared with the size equal to 4. Now I want to make the size equal to 8. So what I will do is int a square bracket is equal to uh, new size is 8. In parentheses, I will write the same array. So all the previous values of A will be copied into the new array and size will be 8 now instead of 4. Next method is size. It returns the current size of dynamic array. For an example, int j equal to address dot size. So the dynamic array named AWDR, I will get the size of it into variable j. How can this variable be useful for, say, I want to make quadruple array of AWDR? So what I'll do is AWDR equal to new. In size, I will use this AWDR dot size into 4 and in parentheses AWDR itself. So now I'm having quadruple address array. Let's say if I want to delete any array while runtime, I can do it. For an example, I'm having int ab of size 4 and I want to delete it. So simply ab dot delete will make the size of dynamic array 0. Now we'll look at the example of dynamic array so it will get more clear. Let's start writing some code here. I'm taking one dynamic array of integer data type, say int a. Next, I'm taking one unpacked array b having size 4 equal to. I will use the array literal that we just saw into the PPT, say 1, 2, 3, 4. So what I did here, I had one unpacked array having values 1, 2, 3, 4 respectively. Now let's write some procedure. Initial begin. What I want to do is, first of all, I am assigning new variable to dynamic array having values 4. Now let's display something. So I'll have one for loop for int I equal to 0. I should be less than a dot size. Here I used one of the method size. Then I plus plus. Let's display the size and all the values of this dynamic array. So a of percentage 0d equal to percentage 0d and size of a equal to again percentage 0d, assigning values, say first of all a of I equal to the value, so a of I, and here the size of dynamic array, so a dot size. First of all, let's run this code, then we'll make some modifications and run again. Compiling dynamic array.sv, compile clean, running it. Here I'm able to see a of 0 to a of 3 created having default value 0 as we have not assigned anything to dynamic array, and my size of array is 4. Okay, so now let's do some exercise on dynamic array. First of all, I will display some amount of new lines so we can differentiate between old and new displays. Now let's do one thing. My a equal to new 4, in parentheses I'm writing b. So what this should do, a should be created having size 4 and value of b, which is 1 2 3 4, should be copied to a. So now let's display it. um, just copying and pasting this for and display statement. Okay, let's run this. compile clean and send. Now I'm having display a of 0, we're having value 1, next 2, 3, 4. The size of array is 4. So my values from B is being copied to dynamic array A. Now let's have one more exercise of changing the size of dynamic array. So I want to just change the size of A from 4 to 8. So what I will do, I will write here the same dynamic array A. So this will get copied to the new array having size 8. Now again, let's having the same display with some intervals in between. Okay, let's run the new code. Okay, this is my last display. This was the first display having default value 0. The next display of having valued copied from B. And now I am having A of size 8, and the values from 4 to 7 are having default value 0, and 0 to 3 they are the same as previous one. So I have extended the size of dynamic array to 8 from 4. And lastly, let's do one thing, a dot delete method. So this should totally delete the dynamic array. Now I'm having dollar display. I just need to display the size of this array as I'm expecting it to be 0. So size of array equal to percentage 0t a dot size, and just making some new line. Let's run this. Alright, so size of my array is 0 as it's being deleted. So we are having enough exercise of dynamic array. We saw how to declare one dynamic array, how to use new method, how to copy some array from B to A, how to extend or say change the size of any dynamic array, and how to delete it. So now I'm having one exercise of dynamic array. Just go through this exercise, and if you have any question, ask into the comment area. Next is associative array. Dynamic array that we saw, it is good with contiguous data collection when size changes dynamically. But when the size of the collection is unknown, or say data space is sparse, I'll prefer using associative array. What do I mean by saying data space is sparse? Let's say I want one location of array, say 1, another location say 1000, and third location say 1 million. Now, if I'm using dynamic array for having just 3 locations into my array, what will be my size array of dynamic array? It will be 1 million. So I'm having size of 1 million of one array for utilizing just 3 members. But in associative array, we can have a size of array having 3, one location say 1, another 1000, and third one is 1 million. We will look at that into example. And another property of associative array is its index can be of any data type, not only integer as a dynamic array. Say it can be of string data type. So declaration of associative array would be like data type, then array name, and in square bracket index type. For an example, int abc of data type string. So my associative array data type is integer, and index type is string. Another example, I will use extract over here. So say integer def then star. So this star makes the index unspecified. We can have any data type over here, and my data type is integer, and index type it can be anyone. So how associative arrays do this? They do not have any storage allocated until it is used. So whenever I will make a new assignment to associative array, it will provide memory allocation for that. So now we'll look at the example, but before that, Let's just go through some of the methods. Say num and size, which returns the number of entries into the associative array. Delete, it removes entry at specific index. Exist, it checks whether any element exists at specific index or not. Then first, that returns the value of first index of my associative array. Then last, it returns the value of last index of an array. Next, that returns the smallest index whose value is greater than given index, and previous, the reverse of next. So let's look at the example of associative array that I told that it can be used when we are having different data, different index type and sparse data space. So what I'll do here is I will make one associative array of integers having data type star. So they can be having any data type. Now let's write some procedure. Initial begin. First of all, I am having ABC of 1 equal to value 2. So my data type is integer here. Next, I am writing ABC of, say, some string hello. This is equal to value 3. My values will always be integer as my associative array is of integer data type, but my index type can be anything. Here it was integer, now I'm having string. I can also be having, say, some binary value 4p0101 equal to 4. I can have, say, 1. This much zeros. This equal to 5. As I told, I want one location of 1, another of, say, 1 million. I can just have this many members into my array. I don't need the size of 1 million for getting the index of 1 million in associative array. Now let's display something. Color display. I want to display the number of entries into this associative array so that we can check whether it is from 1 to, say, 1 million or just 4 size. So let's print it. Percentage 0 d number of entries and abc dot num. It's given into the method that we can have this method for number of entries. I'll also having one more display. I will use this exist method. Let's say whether hello data type, sorry, hello index type, does it exist into the array or not. So I will say abc dot exists and hello data hello. So if hello exists into the ABC, it will return me 1 or it will return 0 if it doesn't exist. Let's run this code associative array.sv. So here I am having display that 4 number of entries. So as I told you, this array is having only 4 members inside it, though my one index is 1, another is very big. And hello exists equal to 1. So my hello does exist into the index of ABC. So here we saw the necessity of associative array in SystemVerilog. We'll be having one exercise so that we can play with different methods of associative array. Go through the exercise, ask for any doubt. The last data type of today's lecture is Q. Q is variable size ordered collection of homogeneous element. Uh, Basically, I will say this increments and decrements automatically at runtime, but it needs to be in ordered collection. The declaration of Q can be using dollar symbol. So if I want to make a queue of bytes, I will say byte q1 in square bracket dollar. So this is a queue of bytes, and here dollar represents the last element. Then another example says string q2 dollar. So this is a queue of strings having initialized to hello. Another integer q, so say int q3 dollar equal to 3 to 7. So here I have initialized queue of integers. I'm having some methods of queue also. Say size, it returns the number. Insert, I can insert any item at specific index. Delete, it deletes the item. Now this four: pop front, pop back, push front, and push back. This helps us making a FIFO LIFO from queue. When I say pop front, I means remove and return the first element of queue. So from the queue, the first element, say from front, it is being removed. Pop back, the last element of the queue is being removed. Push front, I'm inserting some element at front of the queue, and push back, I'm inserting some element at last of the queue. Now let's go through some code of queue also. We will take one integer q, say int q dollar. I'm taking one more integer I. Now let's write some procedure. Initial begin. First of all, I'm using method say push front. So q dot push front value 1. So this one should get pushed from the front side of the queue. Now I'm making copy of this statement and having values 1, 2, 3, 4 using push front. Now let's display something. So dollar display. Let's display the size of the queue. So size of queue equal to percentage 0d, and I will use the function q dot size. And I also want to display the elements of queue. I will use for each loop for displaying it. For each uh, queue of I, begin and dollar display. Let's just print q of I directly here. So what I'm done is I have inserted four elements, one, two, three from four from front of the queue. Then I'm displaying it. Let's run and see what happens. Q.sv. Here I'm having size of queue equal to 4 because I've inserted 4 elements into the queue, and my elements into the queue are 4, 3, 2, 1. It's in the reverse order. Why? Because my first method was push front 1. Then I from the front side itself I inserted 2, 3, 4. So what is at the topmost element of queue? It's 4, and in reverse order I'm getting this 4, 3, 2, 1. Now let's do one thing. Let's use pop front function also. So I will say q dot pop front, and all this displays again. What I've done here is I am having one element removed from front side. So let's see what happens. I think I forgot to save. I'll have to run it again. It's error q dot pop front. Okay, this end statement should be error. all the statements. Let's run it one more time. All right, it's compiled clean. So simulation. Now I'm having size of q equal to 3 and my elements of q are 3 to 1 because I use pop front function. It removed the first element of the q, say 4. So this is my size of q and elements of q's. Exercise for Q, you need to make a FIFO, that is first in first out, as well as LIFO, last in first out, of given dimensions using Q and its methods. This is somewhat difficult exercise, so I have given here that which methods will help you writing the code. Okay, so this is it for the today's lecture. Hope it was helpful, and see you in the next session. Thank you.